The butt-flat welding of CO2 gas-shielded welding plate is the most commonly used welding method in ship construction. In actual operation, the molten pool is suspended due to the suspension of the lower part of the steel plate. Under the action of gravity and arc blowing force, the molten pool metal is very easy to sag. Defects such as weld flash, burn through, and incomplete penetration are easily generated at the root during bottom welding. So, how to prevent these defects from happening? In this lesson, we will learn the butt-flat welding of CO2 gas-shielded welding plates. Learning objectives. 1. Understand the characteristics of butt-flat welding of CO2 gas-shielded welding plates. 2. Master the technical requirements and operation techniques of butt and flat welding of CO2 gas-shielded welding plates. 3. Correct selection of welding parameters. Below, we take the thickness of 12 mm as an example to explain the operation skills of butt-flat welding of CO2 gas-shielded welding plates. Please read the workpiece pattern, complete the welding task, and meet the technical requirements of the workpiece pattern. The welding operation is divided into 3 layers: the bottom layer, the filling layer and the cover layer. Please follow my video to learn. Assembly tack welding. Wire diameter 1.2 mm, welding current 132 amps. Arc voltage 20.8 V, gas flow 13 to 15 liters per minute. Assemble the polished test plate into a V-groove butt joint. The starting welding end of the assembly gap is 3.2 mm, and a 3.2 mm electrode can be used to measure and ensure the gap size. The terminal welding end is 4 mm, and the gap size can also be measured with a 4 mm electrode. Use a steel ruler to check whether the test plate to be assembled has wrong edges. Within 20 mm of the start and end of the weld, use the 1.2 mm wire of the same material as the formal welding for tack welding. The tack weld is 10 to 15 mm long, and is welded by spot welding and continuous arc welding reinforcement. The tack weld should be in the groove on the front of the test plate, and the weld must ensure penetration. And the quality requirements are the same as the formal weld. Prefabricated anti-deformation. During the welding process, due to the uneven lateral shrinkage of the weld in the thickness direction, the relative angle between the two specimens will change, resulting in angular deformation. In order to prevent the angular deformation of the test plate after welding, tap the test plate in the opposite direction with tools such as a handhammer after tack welding, and prefabricate the appropriate anti-deformation. Generally, the anti-deformation angle is 3 to 4 degrees. In order to facilitate the measurement, the prefabricated deformation of the 12 mm test plate is usually about 4 mm. Bottom layer welding. Wire diameter 1.2 mm, welding current 124 amps. Arc voltage 20.8 volts, gas flow 13 to 15 liters per minute. The bottom layer welding is performed by continuous arc welding left welding method. The back inclination angle between the welding torch and the welding seam is 70 to 80 degrees, and the horizontal angle between the welding torch and the test plate is 80 to 90 degrees. Welding is performed by oscillating the wire in a small zigzag or crescent shape. During the welding process, the edge of the fusion hole is always kept 0.5 to 1 mm above the upper and lower roots of the groove, and the arc crater is filled or slightly higher than the surface of the weld at the end. Use a slag hammer and a wire brush to clean the coating and spatter on the surface of the weld. Filler welding. Wire diameter 1.2 mm, welding current 138 amps, arc voltage 22 volts. Gas flow 13 to 15 liters per minute. The filler layer is welded by continuous arc welding left welding method, and the wire is oscillated laterally in a zigzag or reverse crescent shape. In order to prevent defects such as lack of fusion and slag inclusion on both sides of the weld and the base metal, the arc should stop slightly on both sides of the groove when welding the filler layer, and continue to swing after the height of the molten pool is consistent with the middle height. Use a slag hammer and a wire brush to clean the coating and spatter on the surface of the weld. After the welding is completed, the filler layer weld should be 0.5 to 1 mm lower than the edge of the two grooves. Cover welding. Wire diameter 1.2 mm, welding current 138 A, arc voltage 22 volts, gas flow 13 to 15 L per minute. The cover layer is welded by continuous arc welding left welding method, and the wire is oscillated horizontally in a zigzag or crescent shape. In order to prevent defects such as undercuts on both sides of the weld and the base metal, the arc should stop slightly on both sides of the groove when welding the cover layer, and continue to swing after the molten pool fills the arc crater. Use a slag hammer and a wire brush to clean the coating and spatter on the surface of the weld. Workpiece display. The height of the welding seam of the cover layer should be controlled within the range of 0 to 2 mm. Through the operation video just now, we get the following operation skills. 1. Use the anti-deformation method to prevent welding deformation before welding. 2. Maintain the height of the nozzle to prevent undercut. 3. Keep the diameter of the molten hole unchanged by laying the bottom layer, so that the reverse welding seam with uniform width and height can be obtained to prevent the occurrence of welding bumps. Burn through and incomplete penetration. 4. The arc should stay at the root of the groove properly to prevent undercut. 5. The swing of the welding torch of the filling layer in the cover layer is slightly larger than that of the bottom layer to prevent undercut. That's all for this class. Thank you for watching.